Okay, so today we're going to be doing 6.10, which is solving quadratic equations by factoring. Now, let me step back with you and just talk for a second about zero products. We know if I had x times y equaling 0, that either x has to be 0, because 0 times y would be 0, or y has to be 0, because x times 0 is going to be 0. Basically, anything times 0 is 0. So if my answer is 0 and I'm multiplying one of these two guys, or maybe both of them, has to be 0. That's the premise we're going to be operating under today, is you're going to have something times something equals 0. So at least one of these first two terms or binomials is going to have to be 0 to make this a true statement. So now, of course, we're going to throw in some not so pretty numbers, not as easy as the x and y. So I have a binomial x plus 3 times x minus 2 equaling 0. And your directions are to factor and solve this binomial equation. So luckily it's already factored. I've got x plus 3, x minus 2 equaling 0. Now I know that either x plus 3 is going to equal 0 or x minus 2 is going to equal 0, so that one of these is the value of 0, which would give me equaling 0 as my equation statement. So the way you're going to break these out is I usually draw lines like that and set literally each of these binomials equal to 0. And this will let you know, what does x have to be to make this equal 0, or what does x have to be to make this binomial equal to 0. So as I solve this, I'm going to subtract 3 on both sides. So x equals a negative 3. Or solving this side, x could equal 2. So now let's see how this works. So just to prove this to you, what we've done, if x equals negative 3, if I plug this in up here, negative 3 plus 3 times negative 3 minus 2, does that equal 0? I don't know. Negative 3 times 3 is 0, though, times negative 3 minus 2 is a negative 5. Does that equal 0? Yeah, because 0 times negative 5 is 0. So that makes a true statement. And I'll find the same to be true if I go back and plug my positive 2 in up here. If I plug my positive 2 in, I'd have 2 plus 3, which gives me 5, times 2 minus 2, which gives me 0. So 5 times 0, does that equal 0? Again, yes, it does. So negative 3 or 2 are my solutions for solving this quadratic equation. Okay? You're going to typically end up with 2 answers, unless you end up with them being the exact same number. And we'll play with one of those as you go through your notes. But solving a quadratic equation, basically take both binomials, set them equal to 0, and solve. Okay? You may run into an additional step if you have a problem like this one. X squared plus 5x plus 6 equals 0. Well, I can't just set that equal to each piece equal to 0 because I haven't factored it yet. So first you may find yourself needing to factor. So if I need to factor this trinomial equation, I want to keep up with that equaling 0 piece. And again, I want to think about what factors give me a product of 6 and a sum of 5. I know I'm going to have x and an x. And off the top of my head, I know, here's my thought bubble, I could use 1 and 6 or 2 and 3. 2 times 3 gives me 6. 2 plus 3 gives me 5. I'm good to go. And I know that these are both positive, so I'm going to do both pluses. Now is where I begin solving that quadratic equation. I'm going to set each binomial equal to 0, or x plus 3 equals to 0. Solve both of those. So x could be negative 2, or, my marker's getting funny on me here, subtract a 3, x could be a negative 3. So again, you end up with 2 answers. X could be negative 2, or x could be a negative 3. Okay? Let me glance real quickly and see if there's anything else we need to look at. Let's look at one more real quickly. And notice this is your last section in Mod 60, so it's going to pull back up some old ideas. What if I were to give you this one here? Well, there's a lot wrong with that problem if we try to compare it to the two that we've done previously. First of all, I'm not setting it equal to 0. So I need it set equal to 0 so that I can solve this quadratic equation. So let me subtract my 25 and move him back over to this other side of the equal sign. And I'm left with 4x squared minus 25 equals 25 minus 25, which is 0. So now I'm set equal to 0. That's a good thing. And now I need to factor it. Well, how do I factor that? I don't have 3 terms to where I can think of what 2 factors multiply to give me one, add to give me the other. It's not a trinomial. It's just 2 terms there. So let me ask myself, is this maybe a difference of 2 squares? Can I square root this? Yeah, that would be 2x. Can I square root this? Yeah, that would be 5. Am I subtracting? Yeah, so that's the difference of 2 squares. So I keep up with my equaling 0. So I square root this. I said I got 2x. Square root this last term, and I said I got 5. Remember the rule with difference of 2 squares, one's plus, one's minus. So now I'm ready to break it apart and set each equal to 0. Remember that or in the middle, 2x minus 5 equaling 0. Solve this, subtract 5 on each side. So I'm left with 2x equals a negative 5, divide by 2. So x could be a negative 5 halves, or when I add 5 over here, 2x equals 5 divided by 2, on both sides equal sign, x could be 5 halves. So again, I've got 2 answers. X could be a negative 5 halves, or x could be 5 halves. And again, when I plug either of these solutions in for my x and solve it, I should end up, probably here would be the best place to plug it in to solve it, to see that it does equal 0. But if I plug it in here, when I multiply this side out, I should equal 25 as well. Okay, so again, 2 solutions. And that is 6.10. Good luck.